Hello everyone, and welcome back to another GameMaker tutorial video. In this video we'll be going over how to create a server for a multiplayer game, specifically a two-player game. In order to do this, we need to code our server to tether two clients together. Understanding the theory behind this, you'll be able to create a server for a game with 3, 4, or more players. This video will focus on the code of the server. The client code will be covered in the next video, so be sure to subscribe. To test our server, we will use a tic-tac-toe game I created. If you want to be able to download these files and support this channel, be sure to check out my Patreon linked in the description below. Patrons will be able to download the program files for the server as well as the tic-tac-toe game. So by the end of this video, your server will be able to do the following. If we click on the server object, it will turn the server on, and then if I load a tic-tac-toe game open, you'll see that it's waiting for an opponent. And then if I open up a second instance of the game, that message goes away, and then I'll be able to play a game with those two instances. Now if I open up multiple instances of the game, you'll see that the communication for these games will only go to the ones that the server tethers them to. So if I start making moves like this, you'll see that these messages will not go to any other instance of the game. So now let's get into this. The first thing we want to do is create a new project, and we're going to do this in the GameMaker language. And we're going to call this project server. Now the first thing I'm going to do is upload a sprite to represent our server, and I'm going to call this SPR_server. And the sprite I'm going to use will be that of an animated image, so that whenever the server is turned on, we will animate the sprite that represents the server, so we know that it's on. So now let's create the object that will represent the server. We'll call this obj_server. And we're going to set the sprite of that object to be the sprite of the server we just uploaded. In the create event of the server, we're going to initialize a few macros. Now macros are just universal variables that will not change. And we're going to use these macros when we get into the messaging between server and client. These will be explained in more detail later in the video. So now that we have these, we're going to initialize a variable that denotes if the server was created successfully. And we're going to call this variable connected. And we're going to set that equal to false. Next, we're going to force the server object to be in the center of the room using the following lines of code. Lastly, for the create event, we are going to initialize a match counter and create an event that will hold 3 variables. These 3 variables will be the first player socket ID, the second player socket ID, and a Boolean value that denotes if a game has finished. The server will use this array to direct the message to the correct client. This will be more clear later in the video. Now let's create a draw event. We would like the sprite index of the server to remain still until the server is created. We are going to add a condition statement to the draw event that will force the image index of the server to be 0 if the server is not connected. This will force the Pokeball sprite to remain still. And since we added code to the draw event, we cannot forget the function call drawSelf. The last thing we want to do for the draw event is to write out the rooms we have created and the match counter. When I say room, I'm referring to the point in the match array at where the two players will be tethered together. And we will do this with the following code. And then we want to draw the number of rooms we've created in the center of the room. Now that we have this, let's create an event to create the server. We will do this in a mouse left released event. And let's add the following conditions. If the server is not connected, we're going to connect to the server using the script we will create called server create. And we're going to pass it a value. And then if the server is greater than or equal to 0, and we haven't changed the connected value to true, we will then set that connected value equal to true, which will start the sprite index to move. So for the script call that we will use to create the server, we're going to pass it a port value. The port value is the first number at which the client's ports will be allocated. For example, the first client will have a port of 9000, the second will be at 9001. It is good to use a high number in case the router where the server is communicating through has the lower ports already allocated. For example, the server I set up on my router began at 9000, and since I only allow 100 clients to connect to the server, it will range from 9000 to 9100. So the port value, as well as the maximum amount of clients you want on your server, will need to be remembered for when setting up the server on your router. If you're interested in how to set up a server through your router, let me know in the comments down below. For now, we will be using a server local to the computer at which it is set up on. So now let's create this server create script. We will create two local variables, the port value and a new variable we will call server. We will then use the GML function network create server raw to create our server. And we're going to pass it three values: network socket TCP, the port at which we passed this function, and the maximum amount of clients we want to be able to connect to our server. The type of server we will use is a TCP server for its higher reliability of data transfer. The next thing we need to do is create a buffer that we will use to send to our clients. For that, we will use the following GML function, and that is buffer create. And The values that we're going to pass to that, as you can see here at the bottom, are going to be the buffer size, which we are going to set to 16,384. The type of buffer, it's going to be a fixed buffer, which means the size of the buffer won't change. And the alignment, which we are going to set to 1. Then we are going to return the value of the server we just created. If the server value is less than 0, that means we have failed at creating our server. So when we left released over the server object, it will not set this connected value equal to true. Now, in order to add the communication to the server, we will need to create an async networking event. And in this event, we are going to create a switch statement. And the condition of the switch statement will be async load. The async load is a global DS list variable. When a message is sent to the server, the value of the async load at the type position will be one of the following. So we will treat cases network type connect and network type non-blocking connect the same, since they are both used to connect to the server. When a client attempts to connect to the server, the async value will be network type connect. We will have to create code in order to connect the client to the server. We will do this with a script called server handle connect. And we will pass the script the async load value at position socket. The socket is the address of the client relative to the server. So let's create this script. We will refer to the socket as a socket ID. We will set a local variable called socket ID to argument 0. Next, we're going to put the conditions for when not to connect to the server. Since the server can only hold 100 clients, referring back to the creation code of the server, and this game will hold 2 players per room, if the match count is equal to 50, we want to return out of this script. If the room count is not at max capacity, we'll add the client to a match using a script called setMatch. This script will match the client with an opponent, and we're going to pass it the socket ID. So let's create this script call. So we're going to add the following for loops in order to match the opponent. This first for loop will search all of the rooms, and if there is a room with a player 1, it will fill the next client in the player 2 position as long as the game has not been completed. Again, positions 1 and 2 of the match array are the socket IDs for player 1 and player 2. The third position is a Boolean value that states if the game has finished. This is needed in case in a game that the 2 players finished a match and player 2 leaves but player 1 remains. We do not want to fill that room until it has been completely cleared. Otherwise, we will use the next for loop. And we want to change this to 50. This for loop will set the client to be player 1 in a new room. Now that we have this, let us go to the next async load case condition. That one will be network type data. This is the condition whenever a client is sending the server a message. In this case, we need to tell the server how to handle the message. We will do this using a script called server handle message. And we will pass it two values, the socket ID of the client and the buffer that is being sent to the server. Async load at position ID is the socket ID of the client, and async load at position of buffer is the buffer the client sent. So let's create this script. The first thing we want to do is create the local variables for the socket ID at argument 0 and the buffer at argument 1. When the server receives a message, it needs to determine the opponent so that it sends the correct client the message being sent to the server. And we'll do that by creating a new local variable that we'll call temp2, and we're going to create a script called findOpponent. And we're going to pass it the socket ID of the client that sent us the message, just so we can find the opponent of that socket ID. So let's create this script call before continuing. And we're going to create the socket ID that we're passing it at argument 0. And we're going to find the opponent using this for loop. For I is equal to 0 and I is less than 50, I plus plus. And what this is going to do is this is going to traverse the match array and find the socket ID at argument 0. And if that value is at the match array, we're going to send it the socket ID at the opposing position. For instance, if we found the socket ID at position 0 of the match array, we're going to return the value at match array in position 1. And vice versa. Now that we have this, let's go back to the server handle message script. And we're going to add a while loop. And while true, and then we're going to add an if statement that says if the buffer tell of the buffer in this script call is equal to the buffer size, we are going to break out of this while loop. The purpose of the first for loop is when multiple messages are sent at the same time from one client, it will combine those messages into one buffer so that the script will need to loop until that message has been fully read. Since the while loop is always true, we need to break the loop in the instance that the whole message has been read. That is the purpose of this if statement here. If buffer tell, which is the position of the buffer to read, is equal to the size of the buffer, that means the whole message has been read and we can break from the loop. First, we need to read the message ID. And we're going to get that by reading the buffer being sent to the server. And the size of that message that tells us the message ID is size U8. So now that we have the message ID, we can create the switch statement. And if the value of that message ID is equivalent to the macro join room, we will do the code within this case. And then we're going to do the same for if that message ID is equivalent to the macro message turn. Of the macros we created, we left out two, message leave and message get values. This is because these are messages that the server sends to the client, not the other way around. For instance, when a client disconnects from the server will tell the opposing player that their opponent left using the message leave. The client that is leaving doesn't package that message itself. So now the purpose of this video is not to go into detail about the messaging between server and client, only the setup of the server. If you would like to see this setup for the tic-tac-toe game that we are using to test the server, be sure to like this video. If this video gets 100 likes, I will make that video. Otherwise, be sure to tune in for the next video in my How to Create a Card Game series to see how we deal with messages for that game. So, in the first case, the server will send two messages, one to the client that sent the message and one to the opponent. The client will send the player joining their value, which is either X or O, and whether or not they go first. So that's what this is doing right here. And then we're going to send that message to the socket ID of the client that's sending this message, and then we're going to send it the send buffer, and we're going to tell it the size of that buffer. Now, this network send raw is a GameMaker function. If you want more details on this function, be sure to center select it so that it will bring you to the help tab for that function. Now, the next message we're going to send is the message ID that the client sent us, but we're going to send it to its opponent. And the socket ID for the opponent is stored in temp2, which we figured out in the find opponent script call. For the next case, we'll paste the following code. And again, note that we're sending the opponent this information utilizing this temp2 variable. And what this is doing is it's going to send the opponent the message ID that we read here at the beginning, which is equivalent to the macro message turn. And then what this is doing is it's sending the value of the tic-tac-toe board. So if you're creating your own server for your own game, your server code in this handle message should look like this. And you should populate this switch statement with all of the messages you create for your game. Everything that I'm pasting now is specific to my tic-tac-toe game. So now that we have this, the last condition we need to account for is when a client disconnects from the server. We will handle this using a script called server handle disconnect. And we're going to pass it the async value at position socket. So let's create this script call. So since we're passing it the socket ID, we are going to create a local variable called socket ID, and we're going to set that equal to argument 0. The first thing we want to do is find the opponent of the client, and then we want to adjust our match array. So what we're going to do is for I is equal to 0 and I is less than 50, odd plus plus. And we're going to add two conditions. If match array at I, comma 0 is equal to socket ID, we are going to set that value equal to -1. And then we're going to set the value at position 0, or at position 2, equal to true, because when they disconnect, that ends the game, and we don't want to add another client to that room. And then we're going to add another condition for the match array at position 1. And we're going to do the same exact thing. So now that we have this, we need to address the case when both players leave, because when one leaves, it's going to set this Boolean value equal to true, not allowing another player to join that room. But if both players leave, we want to set that value equal to false. So in the object server, we're going to create a step event. And in that step event, we're going to go through the entire match array. And if the value of match array at position 0 is equal to -1, and the value at match array at position 1 is equal to -1, and the value at match array position 2 is true, we want to set the value at match array position 2 equal to false so that we can reutilize that room. But then we want to keep account of how many rooms we have. So we're going to have this variable, match count, and what's going to happen is we're going to traverse the entire match array and if the position of match array at position 0 does not equal -1, or the value at match array position 1 does not equal -1, we are going to increment that match count. And we're doing this so that we can continuously count all of the rooms we have created in our server. Now let's go back to the server handle disconnect, because we haven't finished this yet. Whenever a client leaves, we want to make sure to inform their opponent. So we're going to create another temp2 value, and we're going to set that equal to the script call find opponent, and we're going to pass it the socket ID. And then we're going to create the following message. So we're going to tell the opponent that the client left the game. So this is all of the code you need to create a two-player server. Let's test this using the tic-tac-toe game I created. Again, if you enjoyed this video and want to support this channel, be sure to like, comment, and subscribe, and check out my Patreon linked in the description below. Patrons will not only be able to download the program file for the server, but the program file for the tic-tac-toe game we will use to test the server. So now let's add the server to the room. Let's adjust the room to be the size of the server sprite. And let's load this up. So what we have is our server, and we have a 0 here in the middle because we have 0 rooms created. So let's turn this server on. As you can see, the Pokeball is spinning, which means we've successfully created this server. Now let's open up an instance of our tic-tac-toe game. And it says that we have an error at our server handled message at line 16. And that issue is we have our for loop going from 0 to 100 when we only have 50 rooms. So making this change, our server should now work. So let's reinitiate our server and open up another instance of our tic-tac-toe game. As you can see, it's waiting for an opponent. We have one room created. We have its socket ID here, and we can see at the second position we don't have another player. So let's open up another instance of our tic-tac-toe game. So now we have that, and that socket ID is 2. We still have one room created, and now let's try to communicate between the two. I press X here. I can't go again until the opponent goes, and then I'll select here. So we see that they're successfully communicating to each other. And then if we finish the game, it tells us that we won and that this person lost. But now let's open up more instances of this game. So now we have 2 rooms. 3 rooms. But let's disconnect this one and see what happens. Because we want to create a new room in the instance that this game has been completed. So if I open up another instance of our tic-tac-toe game, we'll see a new room was created and the socket ID is here while this is still empty. Now if I close out of here, we can reuse room 1. But since we have a player in room 4, we want to fill that up before reutilizing room 1. So let's open up another instance of this. As you can see, that room wasn't created. So now let's open up another one and see if room 1 is reutilized. And it is. So let's open up another instance. So now, this room, or this client, will only communicate with this client and vice versa. And this client will only communicate with this client. And this client will only communicate with this client. So we have successfully created a server for a 2-player game. Now, if you wanted to create a server for a 3 or 4-player game, all you'd have to do is adjust this array and some of the logic internal to the server so that it sends the message appropriately. But that's all I'd like to go over in this video. I will see you all in the next one.